All right, so we'll be moving to the next phase of the class, and this is where you'll be learning about. We're actually going to creating an actual conceptual mass from the beginning, like taking it from scratch, and then adding in some building elements in there. So we'll do that right here. Raj will take the first part, and I'll come in if we're adding the other elements. You guys should try to follow along with us because we'll be moving at a very slow pace because it's us. And I'm sure you can follow. And then if you have questions, we'll just address them. Uh, yeah, so Glenn will come in for the second part of the class, and we'll also discuss something if we have time, if we're able to finish the time. So over to you, Rod. Right. Taking to minimize this screen.
Laddie, I made you the presenter, so you can go ahead and share your screen.
Okay, show my screen.
Yep.
So they can see your screen. Okay. Ready?
There you go.
Yeah. All right. So we've learned a lot about how we can actually create a conceptual mass, but then from the conceptual mass, how do we move on to creating an actual building? So a building that has, I mean, how do we convert features from the conceptual mass into like floors or walls or curtain walls or roof? So that's what we're gonna look at right now. So let's go ahead and create a new project. So first, we need to create a conceptual mass. So let's do that. I'm just gonna call it office building for now. We could make this curved so that we can put in a curtain wall later. So I'm using the start and radius arc. Oh, okay. The start and radius arc. Similarly here and here. And we go ahead and select this and we create a solid form. We finish the mass. Let's take a look at it in 3D. We have this. We would also need to add a few levels. So let's go to one of the elevation views. Let me make them 15 feet. And then pick line. So we have a conceptual mass right now. We can go ahead and intersect that with the floors. So uh, this is a conceptual mass, and then we have the mass floors as well. Now let's go ahead and try to create walls and curtain walls. Before that, let's look at this in shaded. Okay, actually, let's start off from the floors. So first, from the conceptual floors, let's try to build the actual floors. So we go to under the massing and site tab, we click on floor. We can choose the type of floor that we need. For now, we could just keep it as generic 12-inch. And then we click on the mass floors. And then we say create floor. Let's try to create a new few sections so that we can see how the floor is. Yes, yeah, I did that. So go back to my level 1 view, and then section, and another section. Double click on this, and if you can see here, the floor has been created. A generic 12-inch floor. Now we go back to the 3D view. We can try and create walls now. For this, again, we go to the massing and site tab, under which we have the option of either creating a wall or a curtain wall. So let's start off by creating a wall. Click on wall by face, and then we want to change the location line to core face exterior. We can choose the type of wall. Let's just say brick on metal stud. So when you click on the walls option, so Revit is smart enough to understand that it can let us choose only wall faces now. So if I just hover over it, I'll be able to select different wall faces. I won't be able to select the floor. So I want my wall here, I want a wall here, and I want a wall here. We can make all of these guys curtain wall. So again, for creating a curtain wall, under the massing and site tab, we have curtain system. Click on that. Select the different faces of the curtain wall. And then once we're done selecting the different faces of the curtain wall, we click on create system. Yeah, sorry. Oh, okay, sorry. So yeah, once we click on different faces of the conceptual mass wherein you want your curtain walls, We then go ahead and click on create system. So far we have our floors, we have our walls, and we also have our curtain walls. Now what's missing is a roof. So for a roof, again, we could use the roof option under massing and site. So we click on roof and then we select the face of the roof and then we say create roof. So now we have the roof, but then there is one disadvantage of creating a roof through a conceptual mass using the roof option under massing and site. If I click on this roof, there's no way for me to make it a slope roof, or I can't really edit its profile or anything. So the best way to actually create a roof in a conceptual mass is to do it like how we've been doing it in the previous classes. So I get rid of this. I go back to my floor plans in level 4. Under the architecture tab, I click on uh, as in
So like if you have multiple floors, if you want your top three floors to be like make actually to that.
no. You could do it at different times. You could select one of them and then choose whatever you want it to be, and then yeah, and then you go back and then you change it again. We can try that now. Let me first do that. Let me first finish up the roof. Under the architecture tab and the roof, go to roof by footprint. And that. Uh, okay. Let me try this again. Just keep this severity not created in not create like standard roof within architecture. Okay. So yeah, it looks like my curtain wall isn't connected here. Yeah, because of which. All right, but then yeah. So the way you create a roof for a conceptual mass is the best way to do it is actually going back to the roof under architecture tab and then using roof by footprint and creating the roof.
So why wasn't that working?
Which one?
You were just doing.
Oh, my curtain wall isn't connected properly, so I'll have to go back and draw my curtain wall properly.
I'm gonna leave it like this. Is there anything else?
Yeah, the resize of the mask.
Oh yeah.
I'm sorry, could you maybe, I don't know, like, I just don't understand.
Mm-hmm.
Or like, you know, you said that the first one was like hash properly or something. Like, what
Yeah.
could have done to fix it?
So when I drew my conceptual mass initially, I don't think I had drawn the curve properly, because of which it wasn't attached in the end.
Oh,
Yeah.
okay.
So that's what happened. Yeah. Still uncut. No, I'm trying to resize it first. It's still in this. All right. So if we want to resize this after the entire building is built, so we still go back to edit in place, and then we can choose a particular face, and then say we want to make it longer. So we do this. So initially, Revit is not smart enough to understand that it has to resize the walls and the floors and the roof along with the conceptual mass. So what we do is, after resizing the conceptual mass, we then click on a particular element. We would want the wall to extend till the end. So we click on the wall. I'm trying to select the wall. Let me finish this mass once. Yeah. So once I finish the mass, then I can go ahead and click my wall. Which one? Yeah. So using the edit in place, I increase the size of the mass. Once you select this, it'll give you an option of edit in place. If you keep hovering over it, it'll select the whole thing. So you need to keep pressing tab till you are able to select the entire thing. All right. So we select a wall, and then we click on this button that says update to face. You can just press OK, and then the wall is extended to your new size of the conceptual mass. Similarly, we do it with the other face of the wall. Before that, I want to do that to my floors as well. So I have all my floors resized. I want to resize this wall. And finally, I need to resize my roof. So again, click on that and then click on update to face. So here we started off with the conceptual mask and then we added the walls and the roof and the floors. And then we resized the conceptual mask and we resized all our building elements as well. Now, Ladi would continue with grids and laying out beams and columns.
Yeah, I think now is a good time to take that break that we usually take 5 minutes. The second section is actually very important, so you guys want to stick around for that. Glenn is going to talk about how to make conceptual math surfaces and then your actual design architectural services work together. So you want to be around for that. But just before Glenn, I'm going to go through adding some infill elements into this, like structural items and maybe stairways, shafts, that kind of thing. And then Glenn will jump right in. So let's say you guys try to be back here by like 10, 15. That's cool. I see you guys then. What do you say? I don't know what to mean. Oh, okay, like mute us here? Or mute? I think he's always using like the last time inside. Okay, can you ask him if he wants to do Oh, why I couldn't? Because sometimes the curtain wall, when we have a curtain wall, it's difficult to select the edges. So when I yeah, it's just because of the curtain wall. I mean, instead of that you could do, you should just take time. You know how you have to, if you created a roof on curtain wall, it's like quite difficult sometimes. So you kind of have to like mess with it to select the edges of the curtain wall, especially when I did it last time. Yeah, we didn't want to do that, so then it takes time.
How many assignments do we have? Altogether?
Minimum 6.
6. So now we have 3.
So how it's going to be is, so the next assignment is probably going to be something like you will probably create some sort of analysis, and you'll probably have your structural columns and things in that. Then the assignment after that is you're going to be working with the dynamical systems, trying to put in all the ducts and validate things, and then most probably the last assignment is going to be, I mean, once you put in all the MVP stuff, there's obviously going to be a lot of clashes and so the last assignment take most of the time is do a quantity takeoff from the model that you created, and then do a coding model and do a plastic.
3 more?
Three more is a minimum, but if everything is going as per plan, we might get small. It really depends.
We might be sending out the next assignment during the weekend. Just send out an email. We actually will send it out today, so we didn't do that, but we will send it out to you guys.
Okay, so you will do a sport today.
Over the weekend sometime.
Okay.
Yeah. I mean, we make sure that if we give you less time, the assignment will be easier.
Okay, I'm asking because we didn't see coursework.
Oh no, it's still not uploaded. It's still not uploaded.
But we're gonna get today.
Not today, but maybe tomorrow or Saturday.
Yes.
Yeah.
I asked over email, and I also Python programming or maybe you know.
Say again, sorry.
So for rhinoceros, grasshopper is
Yeah.
plugin and Python that is programming in
Yeah,
grasshopper.
yeah,
So
yeah.
do you know a person who is instructed to prefer because of the system language? So I yeah, because I think when he didn't pass
No. Like, you really want to use it right now. That's why I was like,
does it make sense?
he probably will reply you as soon as he can. I know about people who use Python in other departments, but yeah, I know
Yeah,
that.
but I need somebody who is using Chinese program. Yeah, for model building. Because I'm trying to connect with everything.
If Glenn doesn't get back to you in time, you might want to have someone inside you in the cycle lab.
I'm working at
Oh my god, and you don't know?
nobody is for Rhino, and there was no course.
Wow.
So basically, there's not one course on Stanford that is giving any tutorial
No workers?
about Rhino. No, about rhinoceros,
Oh.
which is crazy. I don't understand why.
So you have a very rare skill then, like if you're good at it.
I should teach, yeah.
You should teach it. Go apply for the faculty position and just take it.
Yeah.
But yeah, I'm sure we'll get back to you as soon as you can.
Yeah, okay.
I don't know.
Rhinoceros and
I've heard of rhinoceros.
you guys know so
I haven't. He's worked with us. Because you want to get back to it, huh? You want to get back to it? That was the time you planned, right? Wow, we have so much schedule. Alright, let's just go. Alright, guys. So let's get to the second session.
Actually, Laddie, just so you know, I've joined you, so we're back online.
Huh? Okay. Okay, so what we'll be doing in this session is we'll be adding some building features to the lovely building that Raj just did for us right now. So what we'll be doing is starting with structures, basic structural items. I think Glenn already covered this a bit in the past. So I'll go through putting in grids, columns, and beams real quick. You guys can follow along if you want to. And then from there, we'll go to building cores, like how we could put in like shafts, stairways, and make them go to the top, like multi-story. And yeah, hopefully we're able to squeeze that into the time that we have, and then Glenn is going to jump back in. So let's start with putting in grids. So if you guys remember, that's within the structural tab. And the cool thing about grid is regardless of where you put them in level 1, 2, 3, or 4, or 5, they would always show up on all the other levels, right? Because you kind of need them to snap your building objects to. So yeah, let's just do that. So putting in our grids, you basically want to go from bottom up. So for the grids, I could try to align them to the actual lines for the external one and for the other walls. But as with most things, remember how Glenn does it. It puts it right close to it and then you align it so it locks. So that's what I'm going to be doing here. And then what you also want to take note of is the labels for the grids. So typically for grids, I think it's different standards in different places, but we typically have numbers on the vertical and then letters on the horizontal. So you can identify columns and beams like column A1 or beam 1AB, kind of like that. So let me just go back and let me just put in some quick grids in there. Yeah, I also try to align them so they start at the same point and end at the same point. Not quite sure why I do that, but I think when they do, okay, yeah, when they're on the same line, they kind of automatically lock. The grids lock automatically when they're like on the same line. So if you could do that, that would be like really helpful to you. So objects move relative to the other. Right. So we have all our vertical grids now. Then we could do our horizontal grids. So say we had a more detailed building, we would have like internal walls inside our buildings, and yeah, so we would basically have more stuff to snap our grids to. But in this case, since we have just like an outer skeleton and an outer shell, what we're going to do is just create a few horizontal grids. Really, the goal is to put in a couple of bins and columns. So yeah, we don't really need much. Oh yes, what I should have shown. You guys probably already know this. So the number keeps increasing when you put in grids. It's going to automatically make this number 5 because we had like 4 up at the top. So because we want letters, you can manually change that. You just click and if you're lazy like me, you don't want to keep creating and you want to create a new grid and you don't want to navigate to that, you could just click on that, right click, and then create similar, and then yeah, you could create another grid at an offset or whatever. All right, so we have our grids now. So the first thing I want to do is put in columns. I think Glenn went through this in detail last time, but you typically want to start from level 2 because you are going to be putting within Revit, you're putting the columns top down, right? So under the structures tab, we click on column. Okay, for this exercise, we decided it's best to use concrete because concrete is basically easier to model with. You know, you have to take into account the spacing and then connections and all that other stuff. So we're going to use concrete. So I clicked on the vertical column tool. See, so within here, I don't have like a concrete section type, a concrete column. So we need to load that in. Insert, load family. We're going to try it so you guys could also find this. Structural columns, concrete. We could load all of them in there really, but I just want a concrete, rectangular concrete column. All right, so we have that guy in there now. So, oh, yeah, right now I totally forgot to lock the grids. Yeah, so you want to lock the grids to the elements, like the walls and stuff. And to do that, yes, so within the modify, click on align. The element you want to lock it to, and then that. Okay. Basically go on and do that for all our grids. Yeah, can you? Yeah, typically, and that's kind of what I'm used to, putting the grid line before you put the buildings, because you have an idea of like an outline of what you want to build. So you know, like, okay, there's going to be a space of between grid line 1 and 2, I don't know, 60 feet, and then 70 feet. So you put in the grid ideally, and then you put in the dimension between that. So when you're drawing your walls, you kind of trace your walls to those grid lines, and then you put your columns there and stuff. But because of the way we structured this, we're putting it afterward, which you can still do, is fine. Right, so let's align the horizontal ones as well. Lock it. I don't quite know what I'm going to lock this ones to because they're just hanging on there, but I think you're okay here. Yeah, you could move this one. Yeah, okay. So we have all our grids in place. So going back to inserting the columns. So I already loaded my structural columns in, my concrete columns in. And then what you want to do is basically place them at the intersections of the grids, like that. So you place one here. Yeah, I don't want to place one here because, yeah, it would make my custom wall look ugly. So you can just put it another one here. Oh yeah, and then there's the option of, if I can find it, oh yes, of putting the columns at grids instead of putting them individually. This is a faster way to do it. What I'm going to do is just put for the, yeah, I'm just going to put the column for one floor. And you guys will basically get the gist of it. So you control click all the grids and then you're going to put columns at the intersections of those grids. So when you click finish, we should have all the columns there. We should. Yeah, we do. Although there's some columns we don't want, but we're just gonna ignore that for now. Alright, so let's take a look at it in 3D view. Yeah, so this is what I was trying to avoid. You typically don't want columns here. For columns, you also have the option to see if I could do this. Select it, and then you could make the column go from the bottom level to like the top level 5 if you wanted to. All you have to do is change the top level constraint. That would make your work easier. You could do that, like, yeah, say you're not like really focused on the actual design. But I think for real structural engineers, like some of you can correct me if I'm wrong, columns typically get like smaller as they go higher in the building because the load basically reduces as you go higher and it increases as you go down in the building. So so you might want to change the building section, the column section as you go higher. But for the purpose of this class, you could as well just increase this and then it should go all the way to the top. Yeah. So that's pretty much it for adding columns to your conceptual mass building. So the next step, if there are no any questions. Oh yeah, so you select that column, I'll go through it again. Let me try to select this guy here. I can find it. No, I'm just gonna, okay, this guy here. Column right in the middle of a cutting wall. I'm classy like that. so we select this guy and then you go to the top level and then change that to level 5 or level 4 or whatever. And when you click apply, it basically takes it up to the top. You could do that, or you could do the other method that we've used previously. You could copy all the columns within one floor and then place or align them to selected level. You remember how we did that with the walls? That's another way you could do it. So moving on from there, let's go to adding in bins. To do that, it's pretty much the same procedure. So yes, you would also need to insert concrete beams. And yeah, so you can find another structural framing within your family. So you go to structural framing, also concrete concrete rectangular beam. Load that in there. Right, and then you have that. You could also select what type of beam you want. For this one, let's say we put in a 12 by 24. I'm choosing that because I know the width of my wall is about 12 inches, I think. Yeah, and yeah, so if we have something that's 16 by 24, it's going to be bulging out, and that wouldn't look nice at all. Okay, so we have level 2 automatic. Everything seems to be in order. And then you basically click that. You could also, if you wanted to, oh my gosh, I have so many things open. Close some of this guy we don't need. But that depends on what you are. Yeah, I don't need you. Okay, so with the WT, by using that combination WT, which is basically the tile windows, you can get like 2 screens opened up, and then what you do in the floor plan, you can see in the 3D view. This might be useful to you if you want to see like the direct output of what you're doing, so you know if you're like doing complete rubbish in between, which is what I'm trying to make sure I'm not doing right now. So when structures, BIM. All right, so I think we should be able to see this. Oh yes, you want to make sure your placement level is level 2. All right, put that in. Click. There should be a column here, and you get to the next column. You click, and then you have to start it again. Click. If you can see in the second 3D drawing, it's creating the beams right there in between. You could also use the place at grids option, just like we did for the columns, if you want to make it faster. Click. You also want to place the beams to end the columns, because that's basically how the loads get transferred through a building, from the slab to the beams, from the slab to the beams to the columns, and all the way to the foundation. That's why I'm making sure to click them at. Okay, I didn't click that. Yeah, I'm in time here. Okay. Click. All right. So we placed all the beams for level 1. Yeah, they're in there somewhere. Oh yeah, a great way to do that would be to open up section view. So that a beam? That's a floor. See if we could drag this up. Trying to give you a view of what that beam looks like. Yeah. It's in there somewhere. It's in there. Oh yes, yes, so that's it. See that there. So you have your beams created inside, and you could also copy them to like different floor levels if you wanted to. So that's how you put in your columns. It's the same process as you would do it for the regular structures, and it's the same thing you do in the conceptual mass. But yeah, remember the goal for creating conceptual mass is just to get like a quick framework of how your building would look, so you can perform some analysis with it if you wanted to. So that's about it for beams, grids, beams, and columns. I think what we also wanted to do was, oh yes, put in shafts in there. To do that, which I think most of you already done. Okay, yeah, so we wanted to make the point clear that you don't just typically put in your shafts and your stairway anywhere in the middle, like right in the middle. You basically want to place them dependent on the egress, like depending on the exit or fire exit. So that's why, like in Y2E2, we have them located at opposite sides of the building close to the exit. That's typically what you do in most buildings. So let's say we do that here and try to put in like a shaft. We can put it on any floor really. All we have to do is modify the top level constraint and base level constraint. Just gonna make that bigger because my screen isn't big enough. Okay. So right under structures we have shafts, the same way we have under architecture shaft. Both of them will do the same thing over here. So put in a shaft. Let's put one right here in the front, just so we can see it through our curtain wall system. Select the profile for it. Right. So I'm joining this on the level floor right now, and then level 4 right now, and then we just set the base constraint to level 1. So it's going to create that shaft all the way down to level 1. If we accept that, that should go according to plan. See what that looks like in 3D view. Just disappeared. Let's do that again, but from level 1. Alright, do a rectangle for that. Alright, then we could mess with the top constraint. Let it go all the way to level 4. Base constraint level 1. Set our base offset to -1, which is okay. We can leave it at 0. So it's going to try and we can leave it at 0, and then we apply that. That sets it. Yes. So when we look at that in 3D view, am I drawing it on the right one? Alright, so it went all the way to the top, which we don't really want it to do. We should make it stop at level 3. Yeah, changing that is a bit sketch. Yeah, so you can just change that here if you ever have that problem. Alright, so we have our shafts right through, which is okay. We wanted to do. So we could have stairs in there and make them multi-story, which I'm sure most of you guys already know how to do, but we just do that again. One of you I don't need. Shaft. It's a void. You see, continue. You have to draw walls around the shed. Well, yeah, like railings. You put railings. You can put. Yeah. Yeah, you could put walls around it. But the idea with shafts is just creating a vertical opening within the ground, and letting it cut through multiple floors. And then you can do anything you want. Like you said, you can put a chimney in it, with an elevator in it. No, it doesn't have walls around it. Yeah, we would need to put railings, because like what I'm about to do now is put stairs in there, and then you don't want people like fall into their beds, so you just like put a railing in there, and then everybody's okay. So yeah, you could put in stairs in there. I typically would want, no, go away. Start from level 2, where I can actually see it. Stairs. Yeah, so you would typically check if the treads and risers are everything you want it to be, within the requirement, like Glenn spoke about the last time. And then you place them. Say it starts from here. There you go, there it is. That. Oh, that's that. Okay. Then we have our stairway. We have set that. It should be in there. And then we can look at that 3D view. So we have our step. Oh yeah, but we have a case here where the shaft is still not coming down. We could always go in there and then change that. The shaft wasn't actually getting to the base of the stairs, so we can edit the boundary. Oh, but this is the boundary of the wrong thing. Yeah, I'm trying to find. Oh, Glenn's back. What did you say?
You might want to turn off the mask and see your
Ah, gotcha. Okay, so to turn off the mask, you go to. Yeah, we know you're back, Glenn. Can we hear you?
I'm here, but
Okay.
I'm not sure if it's connecting
So
to
we
your sound
could turn off the mask. We could turn off the mask from over here and just click on this tool within the masking on site, toggle it on and off. Can you show mask by view settings? Yeah? Yeah. So let's check that. Oh yeah. So so the mask flaws were there originally. So we now we turn it off so we can only see like the actual flaws, architectural flaws, and the architectural elements that we put in there. I think that's why I couldn't select the shafts like I wanted to. So yeah, what I'm trying to do here is to edit this sketch. Oh yes, and actually shift this here so the stairway covers it accurately. And then yeah, we have I just said shafts. Yeah. Oh yeah, and you guys probably already know that you could make a multi-story and make it go as far as you want to. You could even make it go out of the building if you wanted. Although I don't know why you'd want to do that, Ladi, but yeah, if you want to go to the roof. Yeah. So yeah, so that's how you would put in the. So that's basically how you work with a conceptual mass, and then you could actually create like an overview of your structure, or what you think it would be. It doesn't have to be 100% accurate at this point, but what was the button to do what now? Oh yeah, it was within the masking on site. Show mask by view settings. So you toggle it on and off here. This to show it. This is to not show it. Yeah. Okay. And let me see for my items there if I covered everything. I think something else we wanted to look at. Oh yes, there was one more thing we want to emphasize before I hand it over to Glenn. So within conceptual mass, it allows you, like say you wanted to put in interior walls and stuff in here. It allows you connect your interior walls to regular type walls. By regular type walls, I mean like vertical walls that actually aren't slanting or anything. When you have like slanting walls, it wouldn't allow you connect to it. So the best way to do that, I guess, is to show it. So I don't know if Glenn, you want to do that as part of what you intend to cover, because we have only 10 minutes. Just let me know.
Sure. So Ladi, can you hear me? If not, hook me to the microphone. Hook me to the speakers.
Glenn, yeah, I can't hear you right now.
Interesting. Let me see if I can make it work. I'm unmuted.
There we go.
I think that I'm
Yeah,
here.
we hear you now.
Okay, there you go. Thank you, Ladi. You have to know how frustrating it is for me to be speaking, and as you all know, I love to talk too much. So thank you for turning it back. It really depends on how does it sound in the room there. You can bring it up if you want to.
Gotcha.
Can you hear me now?
Can you guys hear me?
Okay, perfect.
All right.
Okay, I'm speaking now. You good?
Yeah.
Excellent.
Do you want to hand it over?
Yeah, go ahead and hand it over to me if you can, and then we'll go from there. So maybe I can grab it. Let me see. There we are.
All right.
So let me go ahead and we'll finish up with some things here. First off, I just want to thank Ladi and Raj and Dimi for doing a fantastic job. You guys really you did a great job. You knocked it out of the park today. So thank you very much for being able to pick up and run with this stuff. Hopefully you guys have gotten what you need to kind of get going with this. But yeah, I've been lurking along, and you've really been doing a great job. So thank you very much for helping me out that way. Okay, there are a couple of topics I wanted to go ahead and finish up with just to kind of complete the story. And one of the questions people tend to have when we're working with conceptual masses just has to do with this notion of just how real are these things? How do they work relative to the normal walls that I place in Revit, just using the standard construction methods? And as you're going through and placing some things, this is a slightly different model, but it, I think will ultimately still demonstrate the same point, where we want to talk about just this whole notion of really, for these walls, just how they interoperate with other types of Revit elements. So let me kind of go to level 2, and I'll just sort of demonstrate something quickly, which will hopefully kind of show you just how these things work. So in this model, just another thing that kind of created a mass form. It's not all that different. I have a little bit of a floor. You can see, I have a kind of sloping wall on the front. I have 2 relatively vertical walls on the left and right sides. So all these were generated out of the mass form. Okay, but there's something very special about these walls, which are perfectly vertical. So these walls on the end that are perfectly vertical, even though they got generated out of a mass form, okay, it's still created as a standard Revit wall. So all the things that we're used to walls doing in terms of being able to join and connect and report their properties the way we're used to, those all work just fine. You can see that it has an edited profile. It's all kind of sloped, and we can edit that profile. But it did that for you automatically. This wall, though, although it got generated using the technique Raj showed you from the mass, still very standard. Okay, the sloping wall here on the front, though, this glass wall doesn't. It's a little bit different, and that actually is one of the things that's sort of one of the challenges about working with masses. So we love masses because we can create curved, swoopy, organic walls that do all sorts of interesting things. But as soon as they go non-vertical, all of a sudden we have a lot more modeling work on our hands. And let me just kind of demonstrate what I mean. So I'm up here on the 2nd floor level, and I have the exterior wall. This is the wall that got generated by the mass that is perfectly vertical. So as I go through and try to infill the project, so I'll go through and put in some interior walls. For example, oh, here's a nice interior wall segment. It'll go from wall, interior wall. I'm on level 3. I'm going to go to level 2. Hang on, I'm confused right now. I'm confusing myself. Whoa. Oh. Interesting. Well, good. Put the wall in there. It's kind of doing fine. I can go through and continue to add walls the way I'm used to adding in a typical building project. So there's really nothing special about those walls that got generated on the outside. I'll put this wall in, add some doors in. You'll see there's really nothing special going on here. So I can just keep on working as though I created it not from the floor. The nice thing about the form wall that is perfectly vertical, and that's again the big distinction, that's why I keep on saying it, is that I can just join right to it. And it'll behave just the way you want it to. So for example, here we are, it's joined in there, it's going to look just fine in terms of the room, everything heals up very, very nicely. So that's one of the points that if things stay perfectly vertical, everything's cool. On the other hand, okay, the sloping wall creates more of a difficult situation for us. Let me show you what I mean. I'll put a wall up here, up on the 2nd floor still. Kind of come towards the sloping wall. And I'll keep on pulling. I'll pull further, but you'll see it won't snap. It really doesn't know what to do about snapping and connecting to that sloping wall. Because that sloping wall is a little confusing. It's hard to know what it should snap to, whether it's the top or the bottom or what should happen. So here's the deal. When you have a sloping wall that's been generated with a mass, or a curving wall that's been, or a vertically curving wall generated with a mass, okay, you can't actually automatically get them to connect. So you end up with situations like this, where can you see that that is actually poking out of the building? Okay, so what do we do about situations like that? When you have something like that and you want to clean that wall up, because it's this mass-generated sloping surface and we can't use the automatic tools, we have to be a little more manual about the whole thing. So this is one of those trade-offs about using the sloping walls and the unusual geometries, is that it generates more work for ourselves. So what I can do is say edit profile. Let me switch it over to the right so we're looking at it dead on. Okay, and now I can go through and basically pick that surface. Trim. So this is just using that wall profile stuff that we learned very early in the class. I'll finish that up. And now when we go popping back over there, the wall will look really good. So what do I want to tell you about this relative to your workflow? It's the whole notion that if you're going to go ahead and use sloping walls, that's super. It's going to be a little bit more work in terms of trimming up the walls. That's okay. We can do that ultimately. But if you are going to do that, go ahead and save that for kind of one of your last steps in the process. If you're still working with a form and you might reslope it, you might move that wall, go ahead and put walls in, but have them stop short of the sloping wall, with the idea that you're going to clean it up later, because that cleaning it up as a manual process is just kind of messy. It's not an easy thing to do in terms of doing all that. What I should have done, we kind of see if that does work. Hop over here. I'll edit it again. And we'll finish up on this point. Got that guy. I'm going to edit its profile again. Let me try this just to see. I want to see if I can make this a little bit smarter. I'll pick it, I'll lock it, and then trim it. I think that will now have the effect that if the wall slopes or changes its slope or the wall moves, that the trim to the wall will also move with it. So maybe that's a little bit smarter as a way to approach it. So as we're thinking about these things, always think about the mass as being really the boundary or the guidelines for putting the form in. But if you're going to put a big old flat roof on top of it and the mass is flat on the top, you might just draw it the regular way. If the vertical wall is pretty smart about doing that. One other condition we'll sort of talk about, and we'll save this for Tuesday to do together, is the whole issue down here of those doors. So we do have this issue. Here we are at the bottom. We have that sloping glass wall. We can't really put doors into it very easily. Actually, you could put doors in it. I take that back. It doesn't make a lot of sense to put doors in it because doors don't like to slope and all that type of stuff. So what I'll show you on Tuesday as we get started is a technique where we can kind of carve out a little bit of the math and actually create like more of a vertical vestibule or some little entry where we can make sloping surfaces resolve with vertical surfaces and kind of clean that up. So maybe we'll just save that next time out of respect for your time. Okay, great. That's where we want to finish up for today. That's the basic workflow that you're going to be experimenting with in the next assignment. I apologize we didn't get the assignment description out today, but we'll get that out to you probably tomorrow. You're going to have at least all next week to work on it. So I think you're going to have till the following Tuesday to work on it. But we'll get that out. Hopefully, all the stuff that we're doing in this workflow is starting to gel a little bit and make some sense. And we'll just keep on pushing it as we take these buildings and add more and more detail to them. A real commercial folks work.
All right, Glenn.
That makes sense?
Thanks, guys.
Let's go ahead and adjourn for today. Okay, take care, guys.